Okay, so let's have a go at proving this problem first, which is one of the easy ones. So, like always, I'll set up my my Fitch notation and put the thing I want right at the very bottom. So always put my goal at the bottom. Q implies, P implies R. Alright, so I look at this, and without even thinking about it, I know the only thing I can do to prove this, well, it's an implication. Assume the left, derive the right. What else is there to do, right? So I'm going to do that. P implies, and now I'm going to put the brackets in for right associativity, so it's easy for me to read. And I want to get this. Q implies, P implies R. Okay? Oh wow, it's another implication. I guess I'll just break it up again. So assume the left, derive the right. Assume Q, derive P implies R. Oh wow, it's another implication. Same again. So I'm not even like consciously thinking about this, right? I'm just forced to take this set of rules. Alright? I've got P. I've got P implies Q implies R. So I guess that means I've got Q implies R by implication elimination. I've got Q implies R. I've got Q. So I guess that means R. You see, this proof basically did itself, right? You see everything naturally fall into place by just doing implication eliminations. Proof is done. So we stick in our line numbers and we stick in our rules. 5, 6, 7, 8. Implication introduction, lines 1 through 7. Implication introduction, lines 2 through 6. Implication introduction, again, lines 3 through 5. That was an assumption. That was implication elimination. And again, you should quote, where are we? Here it is. You should quote the P first, and then quote the P implies Q second. So here's the P, line 3. And here's the P implies other stuff, line 1. How do we get this? It was the same thing again. Implication elimination, quote the Q implies R, line 4. Cool. There we go. Not so bad. Let's move on to the next exercise. Okay. P or Q, not Q, therefore P. So I'm given two things here, and I need to get P. So I'll set up my notation like I normally do. I don't know how long this proof is going to be, so I always leave myself lots of space. I guess line 1s and 2s are constrained because it's just the two things I'm given. P or Q, not Q, and then stuff in between, magically get P. Okay, so I look at this, and I look at my little sort of rule of thumbs, expand the obvious things, right? Well, I've got a P or Q here. It's the only thing I can really do is do OR elimination, right? But there's no other way I'm going to be able to get rid of that OR. So I'm going to do that. So I'm going to assume P, and then hopefully somehow get to the goal, and then assume Q, and then somehow get to the goal. Well, this one's easy. If I've assumed P, then I've got P, right? I'm done immediately. So assume P, derive P. Right, that was easy. Let's try to do the other way. So assume Q, and then somehow get to P. Well, I can't get to P directly, but I note I've got Q and I've got not Q, right? So I can put these two things together using this rule here, negation elimination, to get false. On the sheet it's drawn an F. I like to draw an upside down P. It's the same thing. You know, I'll stick with the notation of the course. I'll draw an F. There we go. And then once I've got false, I know I can get anything from false by just assuming the opposite and copying the false down, right? So if I want to get P, well, I assume not P, and then I get a contradiction from the false, so then I get P. There's always a sneaky trick you should remember. If once you got false, you can get anything by assuming the opposite and then copying the false, using proof by contradiction. Very sneaky trick. Alright? Assume P got P, well, duh. Assume Q got P. Therefore, from P or Q, I can get P. Hooray, we're done. So I'll put in my line numbers, and then I gotta put in my rules. Okay, well that was given, and that was given. You don't have to write the given, you can leave it blank, that's fine. This is an assumption. This is just a repeat of line 3. This is an assumption. This is, what do we call it again? Negation elimination by line 5 and line 2. negation, elimination, 5 and 2. This was an assumption. This was a repeat of line 6. I just copied down the false. And then assume not P, derive false, therefore P. By proof by contradiction, lines 7 through 8. I know P or Q is true. If I assume P, I get P. If I assume Q, I get P. Therefore P by or elimination. Or elimination, lines, got to be careful here. I quote where the P or Q is on line 1. I quote the first assumption block, 3 to 4. I quote the second assumption block, 5 to 9. And there we go. We're done. Okay, that wasn't too bad. We basically got away with only applying, like, rule of thumb number 1, where you just, like, expand the only thing you can do. And then here, line 5, I got stuck, so then I did the second thing, assume the opposite of what I want, and go for a contradiction. Okay? So we'll see the next problems will require a bit more finesse. So let's do them now. So we'll get that out of the way. And so now I'm going to have a go at the trickier problem. So I need to prove P or Q or R, not P, not Q, R. What's this problem saying? Well, one of these three guys is true, and it's not P and it's not Q, so I guess it's got to be R, right? That's what this statement is saying. So I'll keep my rule sheet at the ready. You should never do these proofs without having your rule sheet on hand. I mean, I sometimes forget the rules, so it's good to have it. So let's have a crack. So set up my fetch notation, put the R way down the bottom, and then put the three things I'm given. P or Q or R, not P, not Q. 1, 2, 3. And then we'll fill in the rest of the line numbers at the end, but I just know these have to be the first three lines. That or looks like an R, and that R looks like an OR. I'm going to redraw that. Q or R. There, that looks a bit better. Okay. So, well, the only thing I can do is OR elimination and hope for the best, right? Because I have to get rid of this OR somehow. So I guess I'll assume P and hopefully get R, and then assume this junk and hopefully get R. That's my tactic I'm going to use. So I've assumed P. I mean, I get false immediately because those two things contradict each other. And then I can use my sneaky principle of explosion trick to turn the false into whatever I want. And I want the R, right? So I'll assume the not R, and then copy the false, and then I get R by proof by contradiction. So always remember this sneaky trick. As soon as you get false, you can just pull whatever you want out of thin air, right? Alright, so that's one half done. Now I got to assume Q or R. Q or R. And then somehow, I don't know how I'm going to do it, I got to get to R. Alright, what have I got? Well, this itself is another OR, right? And I guess the only way I can break up an OR is by using OR elimination, right? So I guess we're going to do OR elimination again. So if I assume Q, well, that contradicts not Q, right? So I get false, and then I do the same sneaky trick I do before to pull R out of thin air. So not R, assume not R, copy the false, therefore R. And now I got to deal with the, oh, my R's look like ORs. That's really not good. I apologize. R, there we go. So I assumed the left-hand side Q, and I got R. Assume the right-hand side R. I need to get R from R. Okay, that's pretty easy. Done. We did it. Because if you got R, then you've got R, just copy it. And then we're done, right? So what did I do? I've got P or some junk. Assume P, get R. Assume the junk, get R. The junk is Q or R. So how do we get from Q or R to R? I do OR elimination all over again. And it's basically a little sub-proof inside the bigger proof. The proof is complete, so I guess I'll fill in my line numbers at this point. You'll also note I deliberately put a really big gap between assumption blocks, so that way I don't get lost and don't accidentally jump one down. 9, 10, 11, 12, 13, trying to make sure everything lines up, 15, 16, 17, 18. Okay. Given, assumption, false. Where'd that come from? P and not P. So negation, elimination, line 4, line 2. That was an assumption. That was Steely the false from above. And then proof by contradiction lines 6 through 7. Because assume not R, magically get false, therefore R. That was an assumption. That's another assumption. False, where'd that come from? Q and not Q. So negation, elimination, lines 10 and 3. That was an assumption. Steely the false from above. Assume not R, derive garbage, therefore R. Proof by contradiction, lines 12 through 13. So that's one half for the OR elimination done. Assume R, get R by repeating the same thing again. Okay, cool. So I assume Q, I got R. I assume R, I got R. I know at least one of the two things is true. So therefore, I get R by OR elimination, lines, and we be careful here. Let's check our cheat sheet again to see which order we should quote them in. I quote the OR statement. I quote the first assumption block. I quote the second assumption block in that order. All right. So, lost my train of thought. Here we go. So, line 1, lines 4 through 8, lines 9 through 17. No, I'm sorry, I've lost. That's not right. This R comes from just this block here. So, my apologies. It's OR elimination, lines 9, lines 10 through 14, lines 15 through 16. And then this one is OR elimination again, but on the big one. So, OR elimination, line 1, lines 4 through 8, lines 9 through 17. There we go. Okay, that wasn't too bad. It looks pretty yucky when you're just staring at the solution, but you can see how I've come up with it just by directly following the only way I could have applied the rules, right?